section 6.3 determinants. So another very important aspect of algebra or calculations involving matrices includes finding the determinant. So you will find how to find the determinant of a 2 by 2 matrix and 3 by 3 matrix. So you can only find the determinant of a square matrix. So if you've got a matrix with the following entries, 2 by 2 matrix A, B, C, D, then you can either write it as det M, or you could put, when you are finding det M, it could be just written in a straight lines, like a modulus symbol, and that means you're finding determinant. Okay, so the formula is very easy. It's simply A multiplied by D, so you multiply diagonally, starting from top left, minus the other diagonal entries multiplied together, so BC. There you go. So AD minus BC. Okay, so this is determinant. If that value, when you calculate it, is equal to 0, then we call that specific matrix singular. If that value is not 0, then this is a non-singular matrix. What it really means, singular, it doesn't have an inverse matrix, and we'll learn about the inverse matrix later on. So it hasn't got a brother, so it's single on its own. Non-singular, it has got an inverse. Okay, so we're going to just find det of A. So det A, or you could put in straight lines, you just do 6 times 2 minus 5 times 1. Surprisingly, loads of people make mistakes when they do it in their head, so always write it out like this first and then do the calculation. So 12 minus 5, which is 7. Okay, now example 10, A is singular, so straight away when you read that, you know that det A is equal to 0, hasn't got a brother. So if that's the case, let's find what det A is and make it equal to 0. So det A is these two diagonal entries multiplied together, so 4 times 3 minus P, minus these two multiplied together, so it's minus 1 times P plus 2. And that, like I said before, always write it out like this. So multiplying these brackets out, you get 4 times 3, which is 12, minus 4 times P, which is 4P. Here we've got minus 1 times P plus 1, so it's going to be plus P, sorry, plus 2, not plus 1. Okay, so it's 14 minus 3P. But we know that that is det A is equal to 0, so that means that 14 minus 3P is equal to 0, so P is equal to 14 over 3. So this is the only value that would make this matrix singular. Okay, so going to go on to before we go on to example 11, we're going to just find out another definition, something important that you will need to mention when you're finding determinant of a 3 by 3 matrix. So a 3 by 3 matrix is a square matrix with 3 rows and 3 columns. Okay, now in order to find the determinant and then inverse of that matrix, you will need to identify a minor of any given element within that matrix. So a minor of an element of this time element A, it's going to be a 2 by 2 matrix that well, the determinant of the 2 by 2 matrix, so here highlighted in yellow, that you're going to obtain by deleting or covering up the rows and the row and the column that A is contained. Okay, so where A is present. So if you delete this and this, you're going to get left with those 4 entries, and that is, if you find the determinant of that, it's going to be called the minor. Okay, so now for the determinant, we're going to write down the formula for the determinant. So the formula for the determinant is that element A multiplied by det of the matrix 2 by 2 matrix that's left, minus, then you're going to select B. There you go, so it's going to be B, and imagine then deleting the column and the row that contains B. You'll be left with D, G, F, I, and that is D, G, F, I. And once you write it down, you work out det of those four elements, or the 2 by 2 matrix that you obtain by putting them together and multiplying it by B. And lastly, you add C. Now this time you're going to take that entry C and you're going to delete the column and the row that contains C, and you'll be left with this here, a 2 by 2 matrix, and you'll find det of that 2 by 2 matrix and multiplying by that C. And then so you have to work out 3 products. Each product will have the minors. Okay, so these, remember, these are minors of element C, this is the minor of element B and the minor of element A, and you just do A times its minor minus B times its minor plus C times its minor, or det of its minor. That's what you need to do. Okay, so we'll actually have a go at example 11. Oh, they haven't asked us to find determinant yet, but we just need to identify the minus of element element 5 and element 7. So there's element 5. So if I delete those 2 rows, then the one that goes with 5 is going to be det of that matrix that's left. So it's going to be 8 times 3 minus 7 times 1. So diagonal minus diagonal. So 24 minus 7, which is 17. And then 7 is here, right at the bottom. So if I delete that column and that row, I'll be left with these 2 and these 2 together. So for 7, you need to find the matrix of 5 minus 1, 2 and 1. Okay, so it's 5 times 2, which is 5 times 1, not 5 times 2, minus 1 times 2. So it's 5 and plus 2, which is 7. There you go. Okay, so now in example 12, here clearly we need to find the matrix. So remember, we're going to take the first element, so top left one corner, so it's going to be 1. We're going to times it by the matrix, the det of the matrix that's left, so this one. So let me just write it down. And then do minus, you're going to take 2, and you're going to multiply it by the matrix that's left over when you delete those, the column and row that contains that 2. It's going to be 3 minus 1 and 1, 3. And plus last one is going to be 4. And if you cover these 2, you'll be left with 3, 2, minus 1, 4. Okay, so now you just need to find the determinants of each of those 2 by 2 matrices. So it's 2 times 3, which is 6, minus 4 times 1, which is 4. This one 3 times 3, which is 9, minus 1 times minus 1, which is minus 1. And here we've got 3 times 4, which is 12, minus 1 times minus 2, which is minus 2. There you go. You can pop it into the calculator and work it out. So it's 2, that's going to be minus 20, and that's going to be 4 times 14, which is 56. There you go. So it's 58 minus 20, which is 38. Okay, example 13, you are told to find det of matrix A. Now here we've got some entries contain letter K, so you need to be extra careful. So 3, remember this one, you delete these 2, so the row and the column, and you're going to multiply it by the det of whatever is left. There you go, that's the first one. Then you do minus K, and then you'll be left with minus 2, 5, and then 2 and K plus 3. And last one is 0 times, I'll write it down, although if it's 0 you clearly multiply it by anything, it's going to be 0, so you could have just left it at 0. Okay, right, so this one here is going to be 3. In brackets, I'll do 1 times K plus 3 minus 0 times 2, so minus 0. And then you've got minus 2 times K plus 3 minus 10. And then you've got minus 0. So this is going to be 3K plus 9. And this one here gives me minus 2K minus 6 minus 10, so it's going to be minus 16. Times it by minus K, you're going to get plus 2K squared plus 16K. So it's 2K squared, add 19K plus 9. Now you are told that A is singular, and therefore find the possible values of K. Now if K is singular, you're going to have to solve that equal to 0. That tells me that A is 0, which is 2K squared plus 19K plus 9 is equal to 0. So solve it whichever way you want. Formula, factorizing, so it's 2 and 19, so if you put 9 here and 1 here, that would work. 18 plus 1 is 19. Okay, so K can be minus a half, or K is equal to minus 9. Splendid. So that leads to exercise 6C.